Have you ever wondered how doctors can literally see inside your brain without making a single cut? It sounds like straight-up science fiction, right? Well, it's real, and it's all thanks to this mind-blowing piece of tech that uses giant magnets and radio waves to map out your insides. And today, we're going to pull back the curtain and find out exactly how it works.
Right, so what is the secret? How in the world does a machine see stuff that even X-rays miss, all while you're just lying there? That's the big mystery we're cracking today.
And the answer is this thing, the MRI, which stands for magnetic resonance imaging. I know, it kind of looks like a giant donut of pure science, but don't let the simple look fool you. Inside this beast is an incredibly powerful system that basically uses the physics of your own body against itself to spill all its secrets. And the secret weapons it uses? You're going to love this. It boils down to two things: a magnet so powerful it's almost hard to comprehend, and a perfectly aimed blast of radio waves. Yeah, that's it. Magnets and radio. That's the whole toolkit. Okay, so to really get how this works, we need to meet the secret agents that are hiding inside every single one of us. And no, I'm not talking about some government conspiracy. These little guys have been with you from day one.
Say hello to the hydrogen proton. See, your body is mostly water, right? And every single water molecule has hydrogen atoms. Well, the protons inside those atoms, they act like tiny microscopic magnets, and you have billions upon billions of them. These little dudes are the absolute key to everything.
So, on a normal day, inside your body, these little proton magnets are just going wild. They're all spinning and pointing in completely random directions. Just picture it, a billion tiny compasses, and none of them agree on where north is. Total chaos. That's just your body doing its thing. All right, so the very first job of the MRI machine is to get all that chaos under control. It needs to get every single one of our little secret agents to line up and point in the same direction. And to do that, it has to bring out the big guns.
And this is the main magnet. It's basically a massive coil of wire that generates the main magnetic field. When you slide into that tube, you are sliding right into the heart of this incredibly powerful force.
And when I say powerful, I am not kidding. We're talking up to 60,000 times stronger than the Earth's own magnetic field. Just try to wrap your head around that. That is an insane amount of magnetic force.
So how on earth do you create a magnetic field that strong and keep it stable? The secret is something called superconductivity. They take these huge magnetic coils and bathe them in liquid helium, which chills them down to, get this, minus 452 degrees Fahrenheit. That's just a whisper away from absolute zero. At that crazy temperature, electrical resistance just vanishes. It's gone. That allows a massive electrical current to flow non-stop, generating that colossal, stable magnetic field.
Okay, so here's the payoff. When your body, with all its chaotic little protons, enters this insane magnetic field, it's like a drill sergeant screams, "Attention!" And almost instantly, billions of your little proton compasses snap into formation, all pointing in the exact same direction. Order from chaos.
All right, mission accomplished, right? All our little spies are lined up. But now comes part 2 of the plan. A little controlled disruption. We need to knock them over and see how they get back up.
And to do that, bam! The machine sends a quick blast of radio waves, a radio frequency pulse right into your body. It's a really short, very precise burst of energy.
Now this is the resonance part of magnetic resonance imaging. That radio wave isn't random. It's tuned to the perfect frequency to mess with hydrogen protons. Think of it like a singer hitting that one specific note that shatters a wine glass. The protons absorb that energy, and it gives them just enough of a kick to knock them right out of alignment with the big magnet.
Okay, now for the most important part of this whole operation. The radio pulse turns off, and the protons don't just stay knocked over. Nope, they try to snap back into line, and when they do, they talk. They become little tattletales.
So as these protons relax and snap back into alignment with that big magnetic field, they have to release the energy they just absorbed. And they do that by letting out a tiny, faint radio signal of their own, a little ping, that the MRI machine is listening for very, very carefully.
And this is where the real magic happens, because protons in different kinds of body tissue ping back at different speeds. For example, protons in fatty tissues realign and send back their signals super fast. But protons in watery tissues, like in your organs, they relax and ping back much more slowly. The machine measures the timing of all these different pings, and that's exactly how it can tell the difference between fat, muscle, and organs.
So just imagine it. The computer is hearing millions of these little pings coming from all over your body. But that raises a big question, right? How does it know where each ping is coming from? Well, that's the final brilliant piece of this puzzle. Say hello to the gradient coils. These are another set of electromagnetic coils that get switched on and off really, really fast during the scan. And trust me, if you've ever had an MRI, you are very familiar with what these things do.
You know that super loud, bam, 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 banging and clanking noise you hear inside an MRI? That's not the machine breaking. That is the sound of these gradient coils firing. They're creating tiny changes in the magnetic field, which basically lays a 3D grid over your entire body, giving every single point a unique magnetic address.
So boom, the computer now has all the clues. The gradient coils provide the where, the address on the map, and the timing of the proton pings provides the what. Is it fat? Is it muscle? The computer takes every single signal, notes its timing, plots its exact location on that 3D grid, and uses all that data to build an incredibly detailed 2D cross-section of your body. One slice.
And it doesn't just do this once. The machine repeats this process hundreds of times, building slice after slice after slice. Then, the computer stacks all of those 2D slices together, like a loaf of bread, and bam, you get these absolutely stunning, high-resolution 3D images that let doctors literally fly through your anatomy.
So, why is the MRI such a medical super sleuth? Well, first and foremost, absolutely zero harmful radiation. It's just magnets and radio waves, which is a huge deal compared to X-rays or CT scans. And the level of detail you get in soft tissues, your brain, your spine, your muscles, your joints, is just incredible. It can find problems that other scans would totally miss. It's a game changer for diagnosing diseases.
So, the next time you see one of these giant donut machines or hear the familiar banging sound, you'll know exactly what's happening. It's not magic, it's just mind-bendingly cool physics. A machine that turns the tiniest particles inside of you into informants to draw a map of your inner world. It's basically a giant quantum spy cam powered by physics.